Adam Riess, when discussing the universe and how we understand it, he highlights, setting aside possible measurement errors, a real and exciting possibility. Perhaps we have misinterpreted the universe. A Nobel Prize winner draws our attention to this. The James Webb Telescope shows signs that something unusual is happening in the universe. The most recent observations from James Webb indicate that our cosmos may have changed in such a strange way that there is no clear explanation for it. But what does this mean in concrete terms? Are we truly without answers in the face of the most recent discoveries, or perhaps a new explanation already exists? Adam Riess is considered one of the leading cosmologists of our time. Years ago, the Nobel laureate presented a pioneering study on the expansion of the universe and found a worrying discrepancy in measurements of the Hubble constant. These differences compared to previous measurements became known as Hubble strain. Riess, along with thousands of scientists around the world, eagerly awaited the launch of the James Webb Telescope. The new technology could finally provide evidence about the true nature of the universe and answer questions like Riess's. Were the current measurements wrong, or were the old ones? It was hoped that the telescope would bring the definitive answer. Of course, there was also the possibility that Hubble strain was a still unexplained phenomenon, but nobody wanted to accept that at the time. The Webb telescope surprised scientists because its recent measurements confirmed the accuracy of all previous observations, eliminating the hypothesis of a simple measurement error. The differences found certainly do not occur because our telescopes are measuring incorrectly. Hubble and Webb made two independent measurements using Cepheid variables as a reference, the so-called standard candles, and also using type Ia supernovae. In this context, standard candles are reference elements that scientists use to obtain precise measurements of the universe from the absolute brightness of these phenomena. In practice, the two methods should produce similar results when measuring the expansion of the universe, or more precisely, the rate at which it expands and how this expansion accelerates or decelerates over time. Small differences could indicate variations in the absolute brightness of the standard candle and might be physically explainable. But the discrepancy is so great that Adam Riess suspects this tension is pointing to fundamental aspects of the universe that we do not yet understand. Did Adam Riess find the explanation? Did you know he's considered the father of dark energy? In 2011, he shared the Nobel Prize in Physics with Saul Perlmutter and Brian Schmidt. The three scientists were recognized for discovering that the universe is not only expanding, but is doing so at an accelerated rate. This discovery also shocked researchers because, according to traditional physics, the universe should be slowing down. Imagine the Big Bang as an initial explosion of energy. After that, the universe began to expand, creating matter and occupying an ever-increasing space. According to our current physics, this expansion should lose momentum over time, leading to the idea that the universe would one day run out of energy, so to speak. This gave rise to the Big Freeze theory, where the universe would eventually reach a state of stagnation in the distant future, when all energy is consumed, processes cease, and everything practically freezes. But measurements made by Riess and his colleagues showed the opposite. The expansion of the universe is not slowing down, it is increasing. How is this possible? This unexpected result led to the introduction of the concept of dark energy, a force that no one has seen or measured directly, but which is considered responsible for the accelerated expansion of the universe. To confirm these theories, the Hubble Space Telescope was used before the launch of the James Webb Space Telescope. Adam Riess not only works as a professor of astronomy at Johns Hopkins University, but also at the Space Telescope Science Institute, which is responsible for Hubble. The James Webb Telescope confirms Riess's theory. Think for a moment about your view of the cosmos. You probably imagine a space where objects rotate, appear, and disappear, and you may perceive that this space is getting bigger. This idea may sound strange to us, but it's real. The universe shows evidence on various levels that space is expanding. Until now, the only logical explanation for this was that the universe expanded from an initial point. However, as already mentioned, the universe should slow down at some point, or at least it shouldn't continue accelerating indefinitely. That's where the James Webb Space Telescope and its unique mission come in. In just 2 years of operation, NASA's newest telescope has already revealed several phenomena that reinforce Riess's conclusions. Among them, galaxies so old they shouldn't exist. Furthermore, so far, no clear sign of a dark age or real relics of the Big Bang has been found. Thanks to Webb, we have been able to observe galaxy clusters so vast and so large that they challenge the theory of an isotropic universe. All of this, combined with Hubble's findings, strengthens the idea that perhaps we haven't understood the universe correctly until now. These discoveries could bring about profound changes in science. And it's not just Adam Riess who realizes this. More and more scientists are admitting that there are many unsolved mysteries in cosmology, which may force us to radically rethink our understanding of the universe. Who would have imagined that a telescope could have such a huge impact on the entire cosmology? But the James Webb Space Telescope is no ordinary instrument. It is the best telescope humanity has ever built. No one expected this type of observation. It's as if a completely different universe is suddenly emerging before the researchers' eyes, different from the one they thought they knew. The idea that the universe may be older than previously thought, and that galaxies formed faster and in a different way than older theories predicted, is gaining traction. Perhaps we even have to accept the possibility that the universe is infinite and that we haven't even come close to understanding how matter actually arises. The James Webb Space Telescope also offers observations that cast doubt on the existence of dark matter. If dark matter truly doesn't exist, another pillar of current theories will have fallen. But then, how do we explain the phenomena that led to the creation of this concept? Researchers like Edwin Hubble and Fritz Zwicky predicted that an invisible type of matter should exist, and only with this matter would it be possible to explain the strange rotational behavior of galaxies and other phenomena. There are some alternatives to explain these effects without dark matter, but they are not very consistent. The James Webb Space Telescope also shows that the assumption that the universe looks the same in all directions may be wrong. This uniformity is called isotropy. If it doesn't exist, the current cosmological model will be even more shaken. In the early 2000s, Riess and other researchers introduced the concept of dark energy to explain the accelerated expansion of the universe. However, the existence of this energy has not yet been proven, just like the existence of dark matter. And with these new discoveries, it is expected that the standard model of cosmology will be profoundly revised soon. But where might this lead us? These new worldviews are surprising. Imagine that we live in a cosmos where no physical constant is truly immutable. This would mean that Einstein's theory of the constant speed of light might not be entirely true, that standard candles could never always produce the same result, and that the laws of physics could vary regionally and even over time within the universe. These hypotheses emerged following the most recent JWST results, and some theories go even further. Beyond the idea that our physics describes only a part of the universe, there are approaches that see intelligent forces in dark matter or dark energy. This would mean that the cosmos has something like a soul, or its own form of intelligence, which could explain who created the universe in the first place. And although we are still far from concrete answers, if these unusual assumptions were confirmed, at least we would know that something like a creative intelligence exists. Until now, We have always observed light and matter to understand the universe, but now it is becoming clear that the structures we seek may be hidden in the mysterious darkness of the cosmos around us. Still, none of this has been proven, and we will have to continue observing what is happening before our eyes. What results have we obtained from the latest observations of Webb, and what does this mean for our science? We, human beings, began to explore the environment around us and, at some point, the universe, because we wanted answers to questions like who or what created it, and why does it exist? Perhaps we are now facing a turning point, capable of altering our old worldview so intensely that it will resemble a scientific revolution. Less daring theories simply state that the universe is much older, or even that it has no beginning or end. But then where do the signs of expansion come from? From this arise exciting new ideas, the possibility that the cosmos is influenced by regional currents. You can imagine this as fluctuations, a formation of bubbles that contract or expand in a localized way, reaching different rates of acceleration and expansion. If there never was a grand beginning, that would make sense. It wouldn't be surprising if we'd never found real evidence of the Big Bang, or perhaps just the fact that for a time all the theories fit together so well that they seem to confirm a starting point about 13.8 billion years ago. But in reality, we've never seen definitive proof of it. If we look again at quantum physics and particle physics, we find further evidence that something is wrong with our old view. In the quantum world, we know that the universe must be much more mutable and flexible than we imagined. And you may be surprised to discover that to this day, not a single direct piece of evidence of the actual physical existence of matter has been found in particle physics or cosmology. Even so, based on the observation of material phenomena and the behavior of matter, researchers drew conclusions about forms of energy and forces. This may have been a serious mistake. Subscribe now and stay tuned for many more video hits.